All right, welcome to Mr. Angelo's statistics class. Today we'll be discussing topic 27, the correlation coefficient. So we've looked at the relationship between two quantitative variables from a bivariate set of data collected. And remember, we organized those two variables on a scatter plot so we can investigate the relationship between the two variables. Yeah? So when we're looking at a scatter plot, we want to describe first the form of the data. And we said that was either linear or nonlinear for the purposes of this class. And then we also looked at the direction. And we said that was either positive or negative. And then the last thing we described for our data was the strength of the relationship, the strength. And we said that it was either weak, moderate, or strong. What our correlation coefficient does is allow us to identify a numeric value for the strength of that relationship. Remember, it's only the strength of a linear relationship, so we always have to look at the scatter plot first to determine if a linear model is appropriate. The correlation coefficient will also give us one other thing. It verifies the direction, right? Our R can either be positive or negative, depending on the strength of the relationship. So our correlation coefficient measures the association between two variables without distinguishing between response and explanatory. So if I put the explanatory variable on the y-axis and the response on the x-axis, I'm still going to arrive at the same correlation coefficient. All right, so some characteristics of R, and these are the important things. These are always on multiple choice parts of the AP test. They'll come up on the multiple choice section of my test. So jot each of these down. And much of the classwork we're going to do is going to focus on investigating each of these characteristics. So that's our definition of R statement. It does not distinguish between explanatory and response variables. Also, just with any linear regression models, both variables must be quantitative. Unit changes have no effect. Right? So if I go from centimeters to inches, or inches to feet, or feet to miles, we're going to have the same exact R.
As long as you do it for both x and y.
Yeah. Yes. You don't have to do it for both x and y, just one. Right? You do unit change on either of them, and you'll see. R is always a number between -1 and 1. The closer we get to -1, the closer it is to a perfectly straight negative relationship. And the closer we get to +1, we have a perfect positive linear relationship. Right? So this is just how well all of those points fit into a perfectly straight line. Right?
Can you kind of like further explain that first one? What do you think about it?
So if you, in creating your scatter plot, if you put your explanatory variable and response variable on opposite axes, right, you're still going to get the same R. So it doesn't matter. You don't have to determine explanatory response. If R equals 1 or R equals exactly -1, then all cases fall in a straight line. In general, the closer you get to 1 or -1, the closer you get to a perfectly straight line. If R equals 0, right, means we have a very weak linear relationship. But we're going to investigate this further because it's very possible that there could be a very strong nonlinear relationship. In the worksheet I'm giving you today, we'll show you a case where we get R equals 0 and how it is a perfect parabolic relationship. And R is not resistant, so beware of outliers. our value of R can be affected by what we call in regression analysis or scatter plots, influential observations. Influential observations. Observations that deviate substantially from the overall pattern. All right, so that formula we are largely going to ignore. All right, we're going to do a couple of the components, but it's quite tedious to do all of those calculations. So we'll take it apart to classwork, see how it works. However, we're going to focus on doing this in our calculator. So get out your TI, 83s, 84s, and you should have some sort of list in there. Right? So let me guide you through how to go ahead and turn these on. The first thing you're going to do, push the ON button. Whoa. Next, hit second and the number 0. This is a list of all of the operations available on your calculator. We're going to scroll all the way down until you see this diagnostics on. You're going to hit enter 2 times, and it should say done. Everyone there? All the way down, diagnostics on. Enter 2 times, should say done. All right, so this will turn on our R. The next thing we're going to do, hopefully you have 2 lists in your calculator from last week. Hit stat, go to calc, and then we're going to go to linreg number 4. So stat to the right one, and then down to number 4. Enter. And let's select 2 lists, L1 and L2. And if you have the old calculator, like the old TI-83s, what you're going to do, L1 and then comma L2, just like that, right? Using second 1 and second number 2, get those lists down there. And then we hit enter and calculate, and you'll have the value of R at the very bottom of that. This is actually the function that gives us the complete regression line, right, which we're going to investigate the top of 28. But what we're interested for this particular unit is just that R in the bottom. We're going to look at all the characteristics of R and how we can measure that strength of a linear relationship between 2 quantitative variables. Thank you. Signing out, Andrew Lizzos.